Welcome students to the second lecture on mathematical reasoning. In the first lecture, we have discussed about sentences with truth values. There are sentences of many types. Assertive, interrogative, imperative, exclamatory, etc. Among these, we have seen that some of the assertive sentences can be assigned truth values, true or false. These statements are called mathematically acceptable, in some book you may find the term proposition. So, proposition is a statement or a sentence having truth values true or false, but not both. Towards the end of the last lecture, I was talking about construction of new statements from old one. That means, if we have a statement with its truth value true or false, then how can I construct a new statement from one or more of such old statements? And that is the topic that I will discuss and elaborate in today's lecture. And as I have mentioned, there are two possible ways are negation and compound sentence. I will first start with negation. What is negation? That means the fact that is given, we are denying it. We are denying the fact that is there with us. So, the denial of a statement is called negation. What does it mean? It means that its truth value will be reversed. For example, consider the sentence, the sky is cloudy. What is its negation? So, the negation is it is not the case that the sky is cloudy. That means, if the sky is cloudy is true, then we are saying, or its negation is saying, that that is not the case. That means, the sky is not cloudy. Or it implies this statement, the sky is cloudy, is not true. That implies the sky is cloudy is false. Okay? So, we started with that the sky is cloudy, we assumed it is true, and then we find that by negation we arrive at the fact that the sky is cloudy is false. So, that is the effect of negation, which changes or alters the truth value of a given statement. Another example, consider this statement, suppose the statement 7 is a prime is associated with the truth value false. Then by negating what we should get? We should get the following, that it is not the case that seven is prime is false, which implies 7 is a prime is not false, which implies 7 is a prime is true. Thus, if we start with a statement that is false, then by negating it we can make it true. However, you have to be careful about using not. In real life, it is not always true that by using not we get a completely opposite meaning. For example, consider the boy is very good. What will be its negation? One may think that its negation is the boy is very good, therefore, its negation is the boy is very bad. That is not correct. Actually, its negation is the boy is not very good, which may mean that the boy is good, but he is not very good. So, this is the right interpretation of the negation of the statement the boy is very good. Notation. We typically use tilde or this symbol to denote negation. Also, as you can understand that by writing long sentences all the time, that is difficult and that is not amenable to mathematics. So, while dealing with mathematical reasoning, we assign variables for statements. Typically, we use small letters such as P, Q, R to denote a statement. Therefore, if P is a statement or proposition, then its negation is denoted by not P or this. In this talk, I shall mostly use this notation for denoting negation. Consider another example. Let p equal to all prime numbers are odd. P is all prime numbers are odd. So, its truth value we know that is false, because we know that 2 is a prime number which is not an odd number, rather it is an even number. So, what does negation of p give? So, not p is not all prime numbers are odd, and it should get the truth value t, because original p has a truth value f, therefore, not p gets the truth value t. Now, what is meant by not all prime numbers are odd? Does it mean all prime numbers are even? No, that is not the right interpretation, or it means that there are some prime numbers that are not odd, and in other words, negation of p suggests that there exists at least one prime number which is not odd, or which means that is even. Therefore, we know that not p is true, as 2 is a prime number which is even. Okay? So, we know that the negation of a statement alters its truth value. Therefore, we can always remember the following truth table. If p is true, then not p is false, and if p is false, then not p is true. Therefore, When P is true, negation of P is false. When P is false, negation of P is true. Now, let me digress little bit and define something called truth set. So, what is a truth set? It is a mathematical or logical set containing all the elements that make the given set true. Example, consider the statement M P, M is a month, having 31 days. So, what is the truth set? We know that there are 12 months: January, February, March, April, May, June, July, August, September, October, November and December. So, this is the set of all months. So, M belongs to this, but we also have that having 31 days. So, we know that these are the set of months which have 31 days. So, this is going to be the truth set corresponding to the statement P, that M is a month having 31 days. On the other hand, if P is M is a month having at least 30 days, then we know that except for February, all the remaining months satisfy the above. Therefore, the truth set is all the months minus February. Okay? So, it is the set of all months minus singleton February. Again, consider example. N is a natural number such that square root of n is also a natural number. then the truth set is one, 4, 9, 16, etc. Because these are the squares of integers, therefore, their square root is also going to be a natural number. On the other hand, if my statement is n is a natural number, and its square root is an even number, then the truth set is four, 16, 36, 64, like that. Okay? So, the concept of truth set is clear. What is the advantage? So, when we have all the values, we can see which are the elements of the set are satisfying a statement, then which are the elements that will satisfy the negation of that statement, its complement. The complement of the truth set of statement P is going to be the truth set of negation of P. Illustration. Consider the statement, the sky is cloudy, then its complement is, say P is the sky is cloudy, then negation of P is the sky is not cloudy. If this is the set of all the days and these are the days on which the sky is cloudy, then these are the dates, these are the days on which sky is not cloudy, and they form the truth set of negation of P. We now move to the next topic, which is compound statement. What is the compound statement? When more than one statement are joined through some connectors to produce one bigger statement, then that bigger statement is called a compound statement, and the individual statements which produce this compound statement are called the component statements. In natural language or in natural English, we use many connectors. For example, and, I love mathematics, and I love computer science. So, these are the two component statements which are connected through the connector and it produces the bigger statement I love mathematics and I love computer science. Similarly, there is something called or. Say one can take computer science or one can take biology as electives. So, these are the two component statements which are connected through or and to convey the entire meaning of the bigger sentence. But say mathematics is fun, but sometimes it is difficult. This is another connector that we use in natural language, but when we are talking about mathematical reasoning, we use only 3 connectors. What are they? And, which is a conjunction, and is denoted by this symbol, or, which is disjunction, and denoted by this symbol, and implication, which is denoted by this symbol. So, these are the connectors through which we can join number of propositions to construct a bigger proposition, and the problem is how to compute their truth values. As it is mathematics, we need to have precise rules for that. So, let me first start with conjunction. We start with an example. Consider a statement like this: x is a prime number and x is a even number. We can substitute x with different numbers and see what we get. Case 1 or case A, x equal to 2. So, the statement now becomes 2 is a prime number and 2 is an even number. Now, 2 is a prime number is correct. So, its truth value is t. 2 is an even number, its truth value is t, and we know that 2 is a prime number and 2 is an even number, the whole thing is correct. Therefore, its truth value is also t. Therefore, we get a case where we get t and t is equal to t. That means, a component statement whose truth value is t and another component statement whose truth value is t, if I AND them, then I get the truth value of the component sentence, which is t. Case B, three is a prime number and 3 is an even number. This is false, right, because 3 is not an even number. So, I know that this is true, 3 is a prime number is true, but 3 is a even number is false, and we can see that if I want to judge the truth value of the entire compound statement, that is false. Therefore, we get a case that t and f case C, 6 is a prime number and 6 is a even number. If I look at the whole thing, again this is false, because this is not correct as a whole, but we know that 6 is an even number as a component statement, this is correct, and 6 is a prime number as a component statement is false. So, what we get? F and T is equal to F. Now, let me come to the fourth or the last case. Nine is a prime number and 9 is an even number. So, as a component, we see that this is false, this is false, and the truth value of the entire statement is false. So, this helps us in building the truth table. If P, Q are two statements, then the truth table for and is we know that P can take true, Q is also true, then P and Q is true. If P is true, but Q is false, then P and Q is false. If P is false and Q is true, then also P and Q is false, and if P is false and Q is false, then P and Q is false. So, this gives us the formula to compute the truth value of the compound statement generated by the AND of two individual statements, and this is the formula: true and true is true, true and false is false, false and true is false, and false is false. However, one has to be a little bit cautious while using AND. In English sentences, just the occurrence of the word and does not make it a conjunction. Example: oil and water do not mix together. You cannot interpret it as oil mixed together and oil do not mix together and water do not mix together. That is not correct. So, it is not a conjunction of two statements. But say Ram and Shyam came here. We can split it as Ram came here and Shyam came here, and thereby we get a conjunction of two individual statements. In other words, what I wanted to say is that just because you see an and in a statement, it does not mean that it is going to be a conjunction of two different statements. Now, let me look at disjunction. A compound statement with an or is true if either or both of the component sentences are true. Or in other words, the truth table for or is as follows: P, Q, P or Q. What it says? If P is true and Q is true, this is true. If either of them is true, then the compound is true. So, if P is true and Q is F, still it is true. If P is false and Q is true, then it is true, but if P is false and Q is false, then this is false. So I give you an example. Consider the sentence, the school will give prize to all the students who got 95% in mathematics. Q is the school will give prize to all the students who got 95% in physics. question is, what is P or Q? That means, who are the students who will get prizes, right? So, any student who got 95% in maths or 95% in physics will be given prize. By the school. So, if this is the set of all the students consider these students who have got 95% in maths, and let these be the students who got 95% in physics. So, the school will give prizes anybody who got 95% in maths or 95% in physics. Therefore, it comprises of all the students who satisfy this and all the students who satisfy this. Therefore, this entire set of students will be given prize. Therefore, if you look at who are getting prize, that is true, the entire set is true, which is or which comprises students who have got only 95% in maths, students who have got only 95% in physics, also the set of students who get 95% in both. On the other hand, if instead of or it is and, then the school will give prize only to the intersection of these two sets. So, if I draw them like this, so that the students will get prize, that truth set which belong to only the intersection of these, that means for which both the statements are true, that is they have got 95% in both. So, that is how the truth values of and or are determined. Okay, friends, I stop here today. In the next class, I shall talk about implications and also negation of a compound statement with and negation of a compound statement with or, and how do you compute their truth values by using certain rules.